Warahmatullahi wabarakatuh. I'm Ade Anisa from International Class Program of Science Education 2018. In this video, I will give my conclusion about the video that I have watched. The video title is BBC documentary Atom: The Clash of the Titans. So this is my conclusion. The video tells us about the story of the greatest scientific discovery ever. The discovery that everything is made of the atoms. The vast variety and richness of everything we see around us in the world and beyond. How it's built up, how it's all fits together, is all down to the atoms, and the mysterious law they obey. As scientists delve deep into the atoms, its very part of matter, they unravel nature's most shocking secrets, and they abandon everything what they believe in to create a new world of science. A science that today is underpinned to world physics, chemistry, biology, maybe even life itself. The story is begin. On the 5th October 1906, a German scientist called Ludwig Boltzmann hanged himself in the hotel rooms. He died because his desperation about believing that matter cannot be infinitely divisible into even a smaller pieces. Instead, he argued that ultimately everything is made of basic building atoms blocks. It seems incredible now that Boltzmann's revelation was so controversial then, but 100 years ago, arguing about atoms were real, was considered by most to be waste of time. Although philosophers since Greek had speculated that the world might be made of some kind of basic unit of matter, but then they realized that they were far too small to see even with the greatest microscope. So, in the middle of 19th century, whether or not atom was real, one of scientists is Albert Einstein. Einstein had two papers that had the most impact to the discovery of atoms. The one that made in all difference was a short paper on how tiny grains of pollen dance in the water. Einstein was thinking that the paper is all about the atoms. In the fact, he realized that the jiggling of pollen grains in the water could settle the ringing debate about the reality of atoms forever. His argument was very simple. The pollen will only jiggle if they were being jostled by something else. So Einstein said that the water must be made of tiny atoms like particles which themselves are jiggling and are continually buffering to the pond. If there were no atoms, so the pollen would stay still. So with the mathematics, Einstein proved that the dance of the pollens revolved the size of atoms, each minimally tiny 1/10 of million of a millimeter across. So imagine, if in the single hair of human has an over million of atoms, so there must be a more atom in the glass of the water. The story is continued by the early years of 20th century. The atom had arrived. Scientists would argue that the atom was real were no longer heretics in dramatic sudden reversal. One of the scientists that had most impact to the discovery of atom is Rutherford. Rutherford now that this made a new world 1/10 of million of millimeter across had its own internal structure within the atoms. There was a subatomic world, and Rutherford believed he knew what it looked like. So Rutherford pictured the atoms as a tiny solar system electron. Tiny particle of negative electricity orbit around a mini positive charged object called the nucleus. Rutherford calculated that the nucleus was 10,000 smaller than the atoms itself. The Rutherford imaging was almost immediately a problem surface, and it was a big one according to the tired and trusted science of the times. The electrons should lose their energy run of speed and spiral into the nucleus in less than blink of eye. Their first atom contradicted the known law of science. The atom didn't care that if defies scientific convention, it's almost entirely empty space and it's going to stay that way. So, the second scientist that has most important impact to the discovery of atom is Niels Bohr. So Bohr was so captivated by Rutherford's picture of the atom that he made his mission to solve the puzzle of why the atom didn't collapse and why there was so much empty space. Bohr described the atom not as a solar system, but as a multi-story building. The ground floors where the nucleus lived, with the electron occupying the floors above. So, Bohr's new idea rested on a single, seriously controversial supposition. Why should electron and atom behave as though they were in a multi-story building? There was no precedent for it anywhere else in a science. Bohr's new idea from atom were a shot across the bow of traditional successful science. So, in the middle of 20th century, there was a big conflict between Albert Einstein and Niels Bohr. Einstein arguing Niels Bohr with a mixed successful, with his celebrity status give him a power. So, when he looked ideas like Bohr's idea that seems plucked out of thin air of people listening. So in that case, more people trust Einstein's theory about atom than they believe Bohr's theory about atom. Theory is continued to Prince Louis de Blais. He came from French aristocracy, but he was devoted to physics. He was so wealthy, so he can build his own laboratory. After the war between Albert Einstein and Niels Bohr, the boys became gripped by the mystery and the controversial surrounding the atoms. And then his working experience as a radio operator gave him an intriguing idea, perhaps a radio wave. A radio wave could explain the atoms, because, although invisible, they behave very much like a water waves, like a ripple spreading out across upon radio waves, playing mathematical equation that were reliable. For his PhD thesis, de Blais imagined a kind of radio wave pushing the electron around the atom. He called it a pilot wave. This pilot wave would also hold the electron tightly in its orbit, stopping the atom from collapsing. So Blais thinks the atom is all about a wave they carry, and we understand what waves are, so it's so easy to understand what is an atom. So the next story, we move to Wolfgang Pauli. Wolfgang Pauli is one of Niels Bohr's rising stars. Pauli took Bohr's bizarre quantum jumps idea and turned it into one of the most important concepts in the world of science. Pauli's ideas guessed by an inspiring title of the exclusion principle, because it explains the vast variety of creation. The question that Pauli's idea tried to answer was this: every atom is made of the same simple component, so why do they appear to us in so many different sizes or shapes? Such a rich variety of colors, texture, and chemical properties. So Pauli did was pulled another quantum rule of in the tin of air, which states crudely that each floor can only accommodate a fixed number of electrons. So if we want to add another electron, we have to check a vacancy in the top floor. So if the top floor is full, another floor or shell is created above it for electron. In this way, a single electron can radically change the shape of the atom, and this is in turn affect how the atom behaves and how it fits together with other atoms. Einstein and the others traditionalist scientists hated Halley's idea. For them, Halley's idea is sound too arrogant and unscientific nonsense, but they need to hit back and hit back hard. So far, the debate about new atomic physics has been polite and gentlemanly. Now, the two sides wheel out their biggest gun, two of the greatest names in physics. There were two very contrasting characters who knows each other. For the new revolutionary, science was beaten up over competitive German called Werner Heisenberg, and for the conservative was Emil Schrödinger from Austria. Schrödinger took Bloch's idea of mysterious pilot waves. He argued that the electron actually was a wave of energy vibrating so fast it looked like a cloud around the atom. A cloud like a wave of pure energy, and what more, it came up with a powerful new equation which completely described this wave and so described the whole atom in terms of traditional physics. So, continue the story. Werner Heisenberg was one of Niels Bohr's proteges. He thought the atom was so unique and unusual. It shouldn't be compressed through a simple analogy like a wave, or an orbit, or even a multi-story building. He believed it was time to give up any picture of the atom at all. The atom, he believed, was too crucial, too strange to ever be explained that simple. So he decided to abandon all picture of it and describe it using a pure mathematics alone. He realized that the atom didn't just need to defy visualization, it even defied traditional mathematics. So, in the end of the video, we can conclude that everything in this universe is made of how it interacts and how it all fits together, but it comes at a huge price at its most fundamental level. We have to accept that nature is ruled by a change and probability, that there are certain limits on the sort of question we can ask the atomic world, and most crucial, while an atom is and how it behaves, we have to give up any possibility of imagination what it looks like. Our human nature has forced us to ask questions of everything we see around us in the world. What we have discovered has been beyond air in wildest our imagination. So that's what I can conclude from the video that I have watched. I'm sorry if I have a wrong pronunciation, and thank you. Wassalamualaikum warahmatullahi wabarakatuh.